Okay guys, what I have here is trying to simulate how you change phase from solid to liquid, from liquid to gas. So, in British thermal units, BTU, say I have, it equals 1 British thermal unit is 1 degree Fahrenheit, 144 BTUs, which is the amount of heat that is required to raise one temperature Fahrenheit to 1 pound of water 1 degree Fahrenheit. Okay, so right now what I have is should be at least 32 degrees. If you can see here, I have a whole bunch of ice cubes on this pan. So I'm going to turn it on, and by method of conduction, because you see here the rings, don't touch it because it's hot. Ooh, it's hot. So the method of conduction of so you got three forms of heat: conduction, radiation, and convection. So the method of conduction is when I add heat to the pan, this pan starts to rise because it's in contact with the O-ring here, with the ring here that's giving it heat, and the heat will generate around the pan, giving it conduction heat. And at the same time, it starts to change state of the ice cubes from solid to liquid. Alright, so if we look at the thermometer, we're still at 30. Alright, but it requires, like I said before, 1 British thermal unit to change a pound of ice to liquid to 144 BTUs. So in this case, pretending I'm adding from conduction, radiation, not radiation, but conduction of heat, changing, let me see if that'll stay still, changing, required 144 BTUs, that's the amount of heat, okay, that's the amount of heat that is required to change from solid to liquid, to raise 1 pound of water 1 degree Fahrenheit, 144 BTUs, right? So, by me adding 144 BTUs, now if you can see, you're changing that block of ice, say if it's a block of ice, but it's only ice cubes, that changed into liquid. Alright, so I have it on medium. If I put it on high, I think it'll be quicker. Do not try this at home, people. I am a professional. Okay, as you can see, you're raising the temperature because you're adding heat. You're adding a certain amount of BTUs, which are 144 BTUs, to change solid to liquid. All right, and then as you're gonna see, as my demonstration, you're gonna see that as soon as it becomes all liquid, I should be at, I think, 144, and then when it's completely liquid, then if I keep adding 1,000 more BTUs, then you're gonna see the liquid of ice, the block of ice, turn into liquid, and then from liquid to vapor, changing state. Same thing is happening in your evaporator. Okay, the majority of your freon, like say R22 in your evaporator, changes state. Alright, 40 degree evaporator starts to boil off the freon to become low pressure, low temperature gas. Alright, doesn't require 144 BTUs because it's under pressure in your evaporator. So this is just a quick demonstration. Now I'm going to place the cover on it so that way I can trap and make it go quicker, the heat. Now as you can see, I'm going to take the top off real quick. Now all the ice is melted, but it still hasn't reached 144. Now, as you know, water will start to boil at 212 degrees, all right? So we're going to wait until we get to 212 degrees and we'll start to change the state of the block of ice to liquid. It'll go from block of ice to liquid, and then from liquid to gas. Set my, oops. Let me just take this off for a minute because it's starting to melt my. Now, as you can see, all the ice has melted. Now I'm starting to boil the water. So now I have reached 212 degrees. Remember there was a block of ice before? Now I added 144 BTUs to change from solid to liquid. Now I'm adding 1,000 BTUs to change from liquid to vapor to gas. Now, at 212 degrees Fahrenheit, it starts to change the state from liquid to gas. Now if I put my cover on it, that temperature, because steam is energy, by changing the state, by putting the cover on, I'm trapping that energy. Now, the energy is at 212 degrees because it's changing state. But, because I trapped it, now that steam can be even higher. So let me see if I can give me a little gun here. If you see here, it's about 280, 270 degrees Fahrenheit because I trapped the steam. Now, to take the cover off, I'm boiling off the water, and if I keep boiling it off, it'll start to evaporate until there's no more water. Okay, so I'm going to check the temperature of the water. As you can see, 260 degrees Fahrenheit, almost 300 degrees. At this rate, by adding certain amount, over 1,000 BTUs, okay, in a few seconds, about maybe less than an hour, all this water would evaporate. And then if I put my cover on, what would happen is that now the temperature is even higher. It should be even higher. But that's the glass. It's about 600 degrees Fahrenheit if my thermometer is accurate. So, hopefully, if I take the steam off, now just remember, okay, by me taking the cover off, is still the water starts to boil off at 212 degrees. Doesn't go any higher. The only thing that goes higher is when I put the cover on and I trap the steam. That goes up higher because steam is energy.